Tonight's presentation is titled 3D Printing for Experimental Aircraft Builders. And our presenter is Scott VanderVeen. Scott holds a commercial pilot certificate, instrument rating, over 1,500 hours. He's the owner of Pro Composites Incorporated, where he manufactures the personal cruiser kit aircraft. And he also provides plans and parts and builder support for the Vision aircraft. He's an instructor for the EAA Sport Air workshops, the composite course, and an EAA member and a home builder. Scott, thank you so much for taking the time tonight and sharing with us your information on 3D printing. I'm going to turn control of the presentation over to you.
Well, thanks, Tim, for the intro. And tonight I just want to talk about some of the exciting things that 3D printing has come up, brought us, and namely what I've been doing with it as a hobbyist and how I'm going to most likely incorporate it into the building of the personal cruiser. So tonight I'd like to talk shortly about the brief history of 3D printing, and then go into some of the 3D printers that are out there, some of the materials that you may look into printing with, and also the workflow of taking a CAD model and actually bringing it into a 3D printer. So getting started, and get my slides here. Getting started, it's funny to think that hobbyist 3D printing was in its infancy roughly around 2006. I mean, there was a huge explosion by 2009 with something called the RepRap, which was a grassroots startup of building a small machine that could actually replicate itself, developing various plastic small parts and things that you would assemble. And the thought would be that if enough people put these together, it would replicate itself, and there would be a mass, I guess, expansion and explosion of these 3D printers, which can make themselves and also make all kinds of different parts and intricate things basically around the world. Well, I'm not sure if that's happened just yet, but it sure has led to a lot of 3D printers have come to the market. The next thing that really kind of I think made the explosion happen of 3D printing was a company by the name of MakerBot, which most of us probably heard of. They started out with a very small 3D printer called the Cupcake, and then went on to the Thingomatic, and then later the Replicator, and that was all within just a few years. So by 2010, there was some fairly decent commercial, I guess in their infancy, commercial 3D printers, and then which basically led to many other types of 3D printers, and with their various variants, because originally RepRap was started out as an open source type of endeavor. So this is an example of one of the very early RepRap Mendels, and you can see it looks pretty, I guess, mechanically and electronically involved, but it was able to replicate itself and makes fairly intricate parts. After that came what I mentioned earlier, the MakerBot Replicator. And this is more of a commercialized version, and with that came, because it was fairly open source, the guts and all of that, many companies decided to replicate that or copy it, and you can get all the parts or knockoffs of this unit for quite a very lot of little money. So looking at a couple various printers have come onto the market just within the last 4 or 5 years. You can see that all of them are, you know, even the Dremel here is kind of a knockoff of the original Replicator, and then there's all kinds of different 3D printers that have come out, and it's really difficult to decide which one to buy. I think a lot of us, when we start out, think, well, what's this really going to cost? And I think that kept me on the sidelines for quite a few years. I remember hearing about 3D printing back in 2008 or so, and thought it was kind of a neat idea. But as I looked into it, it was very, I guess you had to be a serious techno geek, a tinkerer, to figure these things out. And And as far as the budget was concerned, they were well over $1,000, maybe $1,200 to $1,500 might get you a rep wrap. Now, obviously, those prices have come down, but it's been, you know, it was very expensive starting off. So, what kind of made me shift to buying my own was the actual cost had come down. In fact, there's quite a few 3D printers on the market now that are in the $400 to $500 range that are very capable. So the cost of the machine, since that's come down, has really made it available to most everyone, and that's what got me into it, is just basically the cost. I think as a home builder, if we see a tool or something that's in the $1,000 to $2,000 range, because we're typically hobbyists, we look at it, it's like, well, I've already got hobbies, and that amount of money is quite a bit to extend for another hobby. But you know, if you're in the range of the $400 or $500 mark, I think for most of us, after we understand the capability of these printers, we actually might want to get one. So I'm going to take a look at the couple of machines that I found fairly inexpensive. First off is the one I ended up purchasing, which is the one on the left here, which is about $500, and that is a CTC Replicator. It's actually a knockoff of the original MakerBot Replicator, and I found it to be a very good useful tool in making numerous parts, and we'll get into that in just a little bit. The other one that's come out on the market recently, which is only $400, is the Wanhao Duplicator i3, and I've got a better couple slides here to kind of show these. The CTC Replicator, roughly $500, and the first thing we're going to ask is, well, how large a part can we build? And roughly 9 inches by 6 by 6 is about the size, maybe just a little under that, but you can get some decent size parts using this, and the quality is I have to say is phenomenal, and we'll get into that in just a little bit. So for $500, you get this shipped to your door, and it'll require some assembly, not a whole lot, but if you've ever worked with an erector set as a kid and don't mind a few hooking up wires and things, it's really not that bad at all. Here's another one which is typically fully assembled. This came out just earlier this year because I've got a larger version of their product. I think this one has a lot of promise. It's about $400, and it actually has a fairly large build volume, roughly 8 by 8 by 7 inches. So you can make some even larger parts with this, and because of I know the quality of this company, I think it's a good bet to consider purchasing one. Moving on here, this is the one that after I got really into 3D printing, this is just over a year ago, by February or March or so, I picked up this one, and this has a build volume of 12 inches by 8 by 23. It was significantly more expensive, but typically you get what you pay for, and this is probably the best bang for your buck as far as print volume goes currently, unless you build your own. So this is what I've kind of moved into, and I really even haven't, although I've printed many parts with it, I really haven't used the full capability of the height that it can offer as far as the entire build volume yet. So I'm still working towards that, and there's a few factors that really affect that, which I'll get into in just a little bit. So the next thing you want to think about is with a 3D printer, what type of build volume would you like? And that has to do with the types of parts you want to make. And I want to back up for just a second. What does really 3D printing do? It basically takes something, I like to think of it as kind of like a precision-guided glue gun, because it will take a plastic and it will heat it up in a hot chamber at the right temperature, closely monitored, and it will squeeze it out a small end, and then it will lay it down layer by layer and build these intricate parts. It's interesting that it's called a 3D printer, I think mainly because if you look at the old, well, an inkjet printer, basically that just goes back and forth, and the paper actually moves itself out in another direction. This adds another axis to it, a z-axis, so as the printer head goes back and forth and around, the z-axis eventually pulls itself away, and you end up getting these very nice, tall, intricate parts. So back to the build volume. How large do you really need as a home builder or someone thinking about this? I would say just the MakerBot replicator that I mentioned is probably a good one to start with, or if for less money, even the that i3 duplicator from Wanhao is a very nice, is a very good value. But here's a couple things that I built with mine that you might be interested in. As a home builder, we you know, the first thing I do in my shop, because I work in composites, is I vacuum up a lot of dust, and often the bag in the shop vac would get clogged, and by having one of these dust separators, it basically removes over 99% of the debris into a separate canister, and then the HEPA filter is able to work along and not be clogged. So here's an item that I designed that is just like many other ones that are available, but this one allows for a full 2.5-inch inlet and outlet for a standard shop vac, and this is something that was printed on the replicator. And it works actually, the short one works great. But, you know, after you decide that, you know, this one worked, I said, what about a taller one? So if I wanted the taller one, which you can see on the left here, it wouldn't quite fit the replicator, but that's when I did print one in the larger machine, and you can see here, it's about 12 to 13 inches tall, and it works just a little bit better than the other one, but it was a phenomenal and a really nice project to work with, just starting off as a home builder, to have something to keep the shop clean. So what about the quality of the items produced? I would say I think the quality is phenomenal. I mean, I don't know if anybody's held a 3D printed part. I know we've seen pictures of printed parts that are possibly on the web, and most of the time they're really tiny objects that are, when you blow them up, you see lots of ridges and things like that, and when you start building larger things, those ridges seem to go away, and you don't notice them a whole lot, and the quality is just, I'm amazed by it. Let me look at a few things here. So I think the quality of items that you will end up eventually be producing will start with, will be affected by the experience level of the actual person operating the machine. There's a few things to think about when you get into 3D printing, and there's a big learning curve. So I'm going to cover that a little bit in further detail in just a little bit. But also the machine is going to give it, there's variances in some machines. Some machines are much handle smaller tolerances better. I think patience is something that we'll look at, and what type of post-processing and what type of material you'll start with. Now, I've got this little thing called the 3D Benchy sitting on here, which is basically a jolly little 3D printing torture test. So I like using that on the 3D printer just to see how well it prints this item. And actually, this is a benchmark test for 3D printers that has come out recently, and as you can see here, if you don't know what you're doing, if you're starting out, or even if you just put the part, you just print the part, you'll have different anomalies you'll have to take a look at, such as in this case, you can see all these hairs and strings and a few different warpages, you know, things that are warped, and that has to do with my experience level with this machine, what I had to, and with the software. And a couple of things I had to do was to reduce how much filament that was put out and how much it gets retracted, and some of the heat settings, and eventually ended up with a very nice smooth part. Now realize these parts are about the size of a matchbox. I mean, look at the intricate details of this, of a little item that's no more than 2.5 inches long. So I think experience level and the learning curve is really going to challenge many builders, home builders, they start off, because it's just not something that lends itself to anything else. There's a lot of research to figure out why, how these things are better printed. Next is the machine, its capabilities and maintenance. So some of the machines out there can print, you know, multiple materials. Some are limited to a couple, and that has to do with whether it's got a heated bed, sometimes whether the item is enclosed and and with that you can do some better materials with an enclosed machine, and also the type of maintenance that you, how well you maintain your machine can actually affect the quality of the parts produced, because if there's any slop or play in these machines, that will come out in the part, how well the part looks. And the second thing, next thing I would like to look at is your patience level. Just getting into 3D printing, you'll see these great looking parts, but anything larger than, I'd say, a few inches will take a few hours to build. And I guess that's my biggest problem is, if I wanted to create something that's, say, to use the full volume of my large machine, it may take 4 days to actually print out something that large. I think the largest or the longest print I did was actually that large dust collector, and I think it took about 40 hours to print, and that was continuous. So if you want something quick, you're going to have to learn patience pretty quick and deal with it. So I think that's something. Next is the post-processing. So after you have these parts, depending how well you're good at running the machine, there may be some cleaning up of the material, removal of the supports if they're required, light sanding, chemical finish. I put that on here as a lot of the some of the materials such as ABS can be cleaned up and smoothed out by using acetone. And lastly, if you need a finish coat, possibly to change its color, if you don't like the color that it was printed in, you can actually think about painting these parts. And onto the material. There's numerous types of materials to be printed with. Some are stronger than others. Obviously, we're all familiar with nylon. We've heard of ABS. There's something called PLA, which is fairly new. It's pretty common in the 3D printing community, polylactic acid, and then a few other ones that have come out that we've heard of. And I will get into a couple of the, a little more of that in just a little bit. But those are some of the things that you'll have to learn about why we use these and stuff like that, and it's kind of part of the learning curve. And what about speed of production? Not only is it just the printer, does it move at a certain rate, but how fast does it take to basically design your own part or something that's, if you download something off of the internet, how quick is that? And then how do you compare that with something you could build in another method? Say, for instance, you have your own wood shop or your own shop, and all you need is a something to hold some drill bits. So why not just pull something out and drill some holes in a block of wood, and you'd be done probably in 20 or 30 minutes, possibly, or even less. But what if you have a seriously complex part? This is where 3D printers really shine, because there's things that you can't even imagine building with standard tools or even some CNC equipment that you can do with 3D printing. So I would say it's relatively slow, relatively speaking, for building large, simple items. But if you have something that's very complex, you're going to save a lot of time prototyping and possibly building it on a 3D printer. And lastly, if you have a bunch of simple parts that are relatively small or medium-sized, and you can put a bunch of them on the printer bed, or build a bunch of those on the printer bed, it will print itself unattended. So there's really no time that you actually have to be there and watch the thing. Otherwise, most likely you'll be mesmerized watching it, as most of us are. But honestly, just to most of the time I set up a part, I get it, watch it start printing, and if it's going pretty well, I turn off the lights and go to bed, and in the morning I've got a bunch of parts ready to go. It's kind of fun to watch. So relative the speed of production, it really depends on what you're comparing it to. If it's a simple large object, well, maybe it's not something you want to 3D print. But if it's complex, 3D printing really lends itself to a design. And what about the learning curve? So I think this was the hardest challenge I had to begin with. It's getting your first 3D printer is fairly daunting experience. Here it is. It's something, a bunch of wires and motors and gears and things, and you're afraid of breaking it. and if something, and maybe one of your first parts turns out, but then you move on to another one and it fails, and then now the learning begins. It's like, why did it fail? What temperatures were I setting, and what type of materials was I using at the time? So, and with that, some of the materials like ABS and PLA, they're fairly easy to work with. I think some of the biggest problems when we're starting out is how to get the materials to stick to the bed. And there's a bunch of different methods to use for that. And the great thing is the information is on the internet now. So because this is basically developed during the internet age, interesting. One of the new manufacturing processes that are out there that you can find everything you want to about this in kind of some great locations on the internet. And a couple resources I like to go to is, you can see on the screen here, one is 3D Werkstan. It's a company, I believe, or a website out of the Netherlands, and if you actually see it, I can probably pull it up here. And let's see here. Here's one of them. So if I pull this up, this is a visual guide to 3D printing, and as you can see here, if you have problems with, say, pillowing per se, you can go click right on this, and it'll actually explain why this is happening. So it's a great resource. I put that up there, and basically all the little nuances you could have with 3D printing can hopefully visually be seen and fixed just by going to this the troubleshooting guide. Additionally, if you want to know more information about the types of materials that are out there and what they're used for, the material guide here that this website has is really detailed, and it's a great resource to go to when you're starting out, and actually after you've been 3D printing for a while. The next thing is how to select your materials, and I think one of the resources I've benefited from is a place called my3dmatter.com, and I'll leave that up for just a little bit. And the guys there have done a lot of testing, materials testing, and there's some great slides and information available on how strong ABS or PLA is, not only in one direction, but in the cross sections of these of the filament as it lays it down. So it's a really these are great resources to really expand your knowledge on 3D printing. The next thing is, as far as the learning curve is concerned, is this machine. If we're going to start out as typical home builders, we buy the cheapest one we can afford, and the reality is they are prone to failure, and that's just the way things are. You get what you pay for typically, and you have to eventually, or you probably will get to learn what's involved in your 3D printer. Here's a little overview of what's inside a 3D printer. Most likely you're going to see some type of Arduino-based processor, which is a small microcomputer with a few controllers that are on there. And in the machine there'll be various motors just with wires hooked up to them, and there'll be a power supply, a heated bed with a thermistor or a thermocouple attached to it, some fans, a hot end. All these things have wires that go to it, and typically what I found is the wires, because the carriages move back and forth, if it's not wired correctly, or if just the fact that they move back and forth so much, and if they're not supported, they actually tend to have a tendency to weaken, and you eventually have to replace the wires. So that's one of the things. A hot end possibly may go bad after a few hundred hours or 1,000 hours. None of mine have gone bad yet, and I've got well over 1,000 hours on them. But these are the basic guts to any 3D printer. There's going to be a series of stepper motors, a power supply or two, a hot heated bed if you have one, some fans. The fans tend to go bad after a while, so you'll have to replace those. But honestly, it'll seem daunting at first, but it's really not that hard to fix these things at all. You open them up, and it's because they are developed so quickly, I think, that all the parts are there. They're not the designs are not so not nearly as locked down as some parts and things that are out there these days. But moving on here, So next on the learning curve is the ability to use CAD and CAM, and I think, or slicer software as it's sort of known in the 3D printing rounds. And I think that's the biggest challenge to, after working with learning how to use the 3D printer, is to be able to use CAD software. So with this, there's a bunch of free things out there that you can go to. Fusion 360 has just come out, I think, in the last couple months, and it's actually free to anybody who's not using it for commercial purposes. So it's developed by AutoCAD, and there's a number of them out there. Tinkercad, SketchUp, which has been out from Google for years. AutoCAD 123D is also a free one. So these are all free CAD software packages that are either internet-based, or some of them you can download. I think these are all internet-based. And then on to some of the more common ones that some of us home builders use, or something like Rhino, and AutoCAD Inventor and SolidWorks if you got that at work, or maybe possibly at home. These are the more expensive ones, and there's learning curve in all of these, but if you pick up one and go with it, you're going to be able to design parts relatively quickly after you master the software and turn them into a prototype or an actual part. So as far as CAM software, once again, it's called a slicer, which is basically in the 3D printing community. If you've done CNC work, like with a CNC mill, or you do that at work, you've probably heard of something like a post processor, which turns things in G-code. This is exactly what a slicer does. And there's a couple different let's see here, a couple different types of slicers and software out there that's free, that basically takes that CAD model, slices it up, and turns it into G-code that allows the machine to print it. One of them is MakerBot Desktop, and one is Repetier, and there's quite a few other ones. Now, if you want to pay for one, and obviously you get what you pay for typically, Simplify 3D is about $150, and but it allows a lot more bells and whistles and things you can allows you to do with that the other ones do not. So it gives you a lot more control over the parts that are going to be printed. One of the things that I've found interesting with this is that, say for instance, you want a very much more dense part than you would in some areas than you would in another part, and this software allows you to do that real easily. Well, what about some of the things that I've printed so far as a hobbyist and as a guy working with experimental aircraft, and basically hundreds of things, but I'm just going to cover just a few of them. One of them is a stick grip that I catted up probably 5 or 6 years ago, and my original intent was that I would probably have I try to mill it on a CNC machine. But it would just take a lot of time for setup and milling and all that, and fixturing and all that. And I said, so I just sort of set on the shelf or back in the computer for quite a few years. Well, after I got the 3D printer, I thought, well, let's give it a shot. And you can see here, it turned out pretty nice, and it allows you to, after the part was done, and it took about 11 hours to print that item. As you can see, though, it's a really useful part, and I think just by adding a top plate and a hat switch on top, I think it would be a really decent usable piece. The next thing that I had worked with is developing fairings for gear legs, and this is for a flat gear leg, but you can see once you understand CAD a little bit, it doesn't take long to go from a part like this to something that's can be printed and tested. And in this case, if you didn't want to make like this has a thickness of approximately 90 thousandths, I could possibly make that even lighter and use that as a form and just put carbon fiber or fiberglass over it, and either use this as a plug or a form for making a simple part out of composite materials. Moving on, tools and jigs. I've done numerous of many tooling and jig parts. Here's an example of just a simple jig that I can use to slip on the side of a 3/4 inch piece of plywood that's been milled on a CNC machine, and then easily drill the side and have it line up with a barrel nut that would be inside there. So it's a really simple jig as an example. Here's the dust collector that I've used quite a bit, and that's been decent. What else? One thing that's come out recently is everyone's probably concerned about ADS-B, a company, rather a grassroots group has put together something called the Stratux, which is by taking a few parts and putting them together, and they're able to actually receive both bands of ADS-B, not only weather but traffic. And what the 3D printers allowed is I designed this little case that holds everything in place, and it's turned out pretty nice. Now it's still a work in progress, but we're thinking about putting some vent holes and things like that in it. But you can see a 3D printer built this, easily printed this part out, and it's, a very usable piece that I think most aircraft builders would use, even at regular pilots or actual pilots in commercial or in non-experimental aircraft to use. Here's a few other parts, miscellaneous things. Here's a NACA duct inlet that's something that could be easily printed. And also a friend of mine had some type of testing box or unit here that the battery cover was missing. So I designed this part and printed it off, and it's just the detail is phenomenal. What these little printers, $500 printers, what they can do. Another thing I'm very excited about and kind of proud of, I guess, is this. This is called the Mostly Printed CNC Multi-Tool, and as you can see here, all the parts that you can see, all the plastic parts here, are actually 3D printed, including the drag chain, all the brackets, all the carriage mechanism, all the brackets here that hold the motors. But basically, this holds a router or a spindle right here. But people have been putting laser heads. They've actually been putting extruders on there and making these into large 3D printers themselves. So this is just another example of how useful, interestingly, a 3D printer created a CNC machine. So all these parts here you can see, even the inlets and the electrical connectivity, the hold down clamps, even the track here was all printed from ABS plastic. And the rails here are made from simple 3/4 conduit. Now this could probably cut very lightweight aluminum, and it might take a while, primarily because it's less rigid because it's a large machine. But for lightweight composite parts that I'm more interested in, this easily cuts through them, and it will even cut through light plywood. So it's just a really fun machine to work with. Mainly as just an experiment to see what it could do, and I've been very impressed with this machine. And this is available on Thingiverse, called the MPCNC. So I want to do a little example of CAD to part and how that works real quick, and hopefully you can follow along here. But I'm going to come up with a simple knob I think that most of us have probably seen before. Is a Piper Cherokee, knob, an old style knob here. Probably got it from a 1950s automobile, and they used that inside the aircraft. And here we have, I'm going to go through the CAD model, how that works here. So to start off with, typically we start out with just a simple design, and I'm going to use AutoCAD Inventor, and I'm going to pull it up real quick and show you how simple this is. Now it's taken me a few years to figure this out, but here's AutoCAD Inventor, and you can see this is a simple line drawing of the side profile, 1/4 of or half the part. And after I kind of get the idea of, say, I want this part to be 1.125 tall, and the width here is, the end is like 1/4 inch wide, and I've got a few angles here, just by adding various lines, and so it doesn't take that long with parametric modeling to actually make a very intricate part very quickly. Once this part was made and I was happy with the profile, I would just hit Finish Sketch. And this will, and the next part is with current cam or or CAD programs is not only can you extrude these parts to basically make a basic shape and thicken it up, but you can actually do a revolve, which is basically selecting the part, select an axis here, and click, and now we have our part, and it's pretty phenomenal if you can see that here. So that's kind of the basis of how easy it is to go to an idea to an actual knob. Now the cool thing is you're going to think, well, what about the threads? Okay, well, I worked on that a little bit farther here, and if you can CAD the threads, which I did here, which required making a hole and adding a profile of the thread and doing something called a coil up inside there. You can see if I switch this over to shaded with hidden edges, you can see internally there's a set of threads, and those threads are 1032 pitch. All right, and I'm going to send this to a cheap 3D printer. Well, how did it turn out? Well, here's the obviously here's the idea ready to go. The next step would be to call up. After I do this, I would just export this to an STL file, which is basically simple export CAD format into an STL, and we'll just call it Piper Knob Red, which I did before, and we'll save that, and I'll hit cancel here because I did it already, and then I would call MakerBot Software. You'll see that in here, it pops right in, and it should pop up. You should see that in just a second. Okay, this is a free package from MakerBot, and the next thing to do would be just to add the part here, or open the part. Here's a Piper Red knob, open. It should move to the platform, and the next thing is to just manipulate the part to the right orientation if needed. All right, lay flat on there. And if you've got a multiple extruder machine like the Replicator, I have to make sure I have the correct filament selected. In this case, it's on the left side. And basically, this is ready to send to the printer. You can see in this case, it's going to stick to the bottom. And interesting enough, it'll print through there and print the entire piece. So I'm going to hit print on this real quick. And it'll determine how long it's basically slicing this item. And it tells me it'll take about an hour and 1 minute to print this knob. So if I hit print preview, which is interesting, you can actually see, if I expand this out a little bit, here we have the part, and I can see each layer that the 3D printer is going to build inside there. So it starts out here, and you can actually see the threads inside as it builds and creates this part. So I think it's pretty fascinating how far along 3D printing has come. So I'm going to close this out and cancel printing, and take a look at the actual part that I built this afternoon. So once that was done, we can actually probably see that. I'll bring this in here. And here's a live little view of this part that was built today, and you actually see the threads inside. I'll get this in camera. There we go. You can actually see 1032 threads were cut in this, and you know, it fits pretty nicely in the palm of my hand, and you know, it's a decent little part, very smooth, and I think this is a very usable part that I think just anybody could probably design or at least download from the internet and print themselves. So I'm going to close this out really quick and go back to here. So that's the basic idea. Here's another part that, if you can see on the slide here, this was printed in PLA. The other one that you saw was printed in ABS. But within an hour, these parts were created, and it's just phenomenal how the quality of them. So moving on here. So what if you want to, you're not really into design, but you want to just download some parts from the internet? Well, here's the workflow for that, and I'll go through that really quick. There's a a couple sites that offer basically free designs. One is called, there's many of them out there. One's called Thingiverse, but there's also Yegi and things like, just a bunch of 3D, I just can't think of them off the top of my head, but Yegi is one of them. But Thingiverse is one that I typically go to, and I'm going to call this in here. If you went to my handle here, which is PC Flyer, and here is the Stratix case right here. So if you were to go to here and you want to download this, you just click on this, and you can see different views of the actual unit that I printed. All the little bells and whistles and things like that. It's amazing just the intricacy here. Here's plugs for the HDMI port, so dust and debris wouldn't get in. So here are the parts, and as Thingiverse gets them, you can see here that these are all ready to go. So next thing is to basically download them. You can see here, download this thing, and you either can select individually which part or download all files, in which case you'll get something called a zip file with all of them built together. In this case, I want to build the ADSB dual top, and you can see here it downloaded that quick. And to print it, the next thing to do, I'm going to close this out, is to go back to the MakerBot software, delete this out, add a file, and I think I've got it in here. Here it is, ADSB dual. There it is, the one I downloaded, and there it is. I'm going to move to platform, and once again, I've got to get the orientation correct just by moving it around, laying it on there, and changing it to the correct extruder. And then I would go ahead and slice this item with the different settings. In this case, there's a few settings here. I would change and usually the instructions on the part at the website will tell you what layer and how hot and things like that to set up, what type of infill and things like that. But there's various parameters, and once that's done, we hit print, and let this go through here, and we'll see how long it would take, or what its estimate to take, how long it would take here. So it's almost done. Yeah, almost there. And this is at a resolution of 0.2 millimeters per layer. This would take about 9 hours or so to print, so it's just amazing. Even with the print preview, you can see here all the intricate layers of how it builds together, layer upon layer upon layer, to build up this case. So I'm going to close this out here, cancel. Yes, closed out saving. Okay, so that's basically the idea. Download a part and then go ahead and print it, and then you have your part when it's done. I suppose I actually got a picture of that one over here, but I can't get to it right now. So moving on here, in conclusion, I'm going to wrap things up, so I'm sure you have a few questions you want to talk about. But I think getting a 3D printer, expect a learning curve and plan to tinker quite a bit starting off. There's still lots of different nuances even within the actual filament that you pick from, such as going from if you're using ABS, some colors actually print different than others. So there'll just be some slight variations within the filament, and realize that your printer may work for a while and then it may stop, and you may have to figure out what's going on. That doesn't happen to everyone, but and some are better than others. But with this day and age, you can actually read reviews and figure out which one has better quality and better support with each printer. You're going to have to probably learn CAD. There's various online courses and free tutorials on the internet, or to consider heading to a local community college for that. If you wanted to learn such a software package like SolidWorks or Inventor, they're many times taught at community colleges, and as a student, you can get a very heavily reduced rate with those. Typically around $200 or $300, you can get a full-blown package to learn this software. And realize that these parts are very usable. They're strong, they're tough. I mean, as tough as ABS plastic can be, and realize more filaments are on the way, things such as nylon, which we're all very familiar with, which are very sturdy and strong, and then also carbon fiber filament is being created. That's carbon fiber is impregnated with, I believe, ABS is being made. So all these filaments are available to make even harder and structural parts. And if you don't want to just stick to your experimental aircraft builder parts, there's millions of things out there already designed that are interesting, such as you can download your own 3D printer, per se, and build one that's a lot larger and is more capable than the ones that are probably currently available for $3,000 to $5,000. Also, check out things at my handle, PC Flyer, if you want to check out some tools and things I've developed. And at Thingiverse, there's many things to check out and look at. So at this point, I'm going to wrap things up now and just go to a few questions that people might have and go from there.
Great, Scott. Yeah, we did get some questions already in here. I'm sure we'll get some more too. Let's start off with Walt's first question, and he's wondering, what physical tolerance can one expect from 3D printing, and does the software manage the thermal expansion or contraction that may occur while you're printing?
Okay, so the first question, the tolerance is amazing. Even though some of these parts look like they're I've dialed things down to 1 or 2 thousandths of an inch. So it really depends on your expertise with using the machine. But after you have it dialed in, you can make repeatable parts that are, I'm trying to think, like I've had it like a couple of microns in diameter variance. It's just unbelievable. And as far as does the software compensate for the shrinkage of these materials, unfortunately it doesn't. So what I found is with ABS, I use about a percentage. I oversize things about a 1.5%, and that's a good ballpark to begin with. And then as the parts print out, you can actually verify them later on and see how close you are. But each filament will have a slightly different shrinkage to them. So a lot of times what you'll do is print off, you typically print off a cube, print that off, or a test pattern. In fact, I've got a nice one here I'm going to go to real quick that I'll show you. I can pull it right here, and you can see this. Here's a simple test pattern that, if you can see this, here we go, that starts out as a 1 millimeter. We can get this here. Here's a little test pattern that I print out when I change filaments. From the left to right, that's a 1 millimeter rod all the way to 2.5 millimeters, and then the box itself, I believe, is 10 millimeters across, somewhere there in the hole, and also the tiny holes that you can see on the back side here. I can just measure those. Hopefully here, get it in focus. But basically, starting out with a simple test piece, you can go ahead and measure and figure out how much you need to manipulate the holes to actually come out with something that requires very little post-processing and cleaning up and re-drilling and stuff like that. So that's one of the tools that I like to use. I'll close this out real quick. Okay.
Cool. Yeah. Hey, that's cool. Josh is wondering, can you print a part over an existing part? Meaning, say you want to build your red Piper knob over an existing threaded and knurled insert.
Okay. There is a way to do that. Typically, if I wanted to do an insert like that, I would probably give enough tolerance, print the part, and then heat up my insert, and then to roughly the glass transition temperature of the filament, and then just slide it in there and let it ooze right around it and be done with it. But as far as printing around other objects, it's what I've seen is what people have done is print to a certain area, pause the machine. Now, you have to get good at this. Pause the machine, move the head out of the way, drop a nut or insert inside there, and continue printing around it. Now, that is possible, but in theory, and it's possible that the machines will allow you to do that. In practice, though, if you bump your part or it bump the machine in any way and it's not real rigid, you're going to have some anomalies show up in the side of the piece as you go. So theoretically, yes, and with practice, you could probably get pretty good at it.
All right, that morphs into a question here I think you just answered, but the question is, for large jobs, can you pause the printer and continue the next day, or must it be continuous?
Oh yes, you can pause the printer and start the next day. The only caveat I would think is, depending on the material you're printing with, some environmental factors affect some filaments more than others. So with ABS, the chamber should probably be the same temperature when you start up again. Otherwise, you're going to notice where you started and where you began again. Some of their materials are more forgiving, like PLA, and you probably won't notice it much at all. But even with that, the changes in variances in surface aren't going to matter a whole lot. Depending if it's a large part, you most likely may sand it and finish it a little bit anyway. So yes, you can start it and pick it up and let it go the next day. But the great thing about these 3D printers is they will run autonomously forever. I mean, there's people who run these for 5 days straight and out comes the part. So I guess that's a benefit of these machines.
Michael's wondering if you could just discuss the strength of the materials and any structural considerations. Can you make a structural part?
Absolutely. What most people, I guess, a lot of times we hold up these parts and they're probably very small, and you could snap them just like if you took a piece of ABS, plastic parts. I mean, you can actually snap them. But what's great about 3D printing is you can change the densities of these materials so that even though, like back with this this control knob that we printed here, the density, just for prototyping, I put at 25%, which is more than enough for most pieces. But outside of it, actually, as it builds, there's the thickness of the top and the side skins are actually a couple millimeters thick. By making a solid piece, you're guaranteed that you're going to make something a lot stronger. Now, it's going to there's material specs on that one site that that I presented earlier that addresses different strengths in different areas. What they have found with PLA, and they didn't do additional testing, was that because of the layer adhesion, it's about in that direction of the z-axis, I guess you would call it. It's about 20% weaker than the other direction, which is if you build for it, you can actually compensate and make rather structural parts. And also how you bolt things together and how they're used can really determine how useful these parts can be.
And Walt wonders, since 3D printing uses slices, is there a concept of grain? In other words, i.e. crack along the plane? Or do all the layers fuse together?
They actually, well, if you're doing it right, and this is the part of the learning curve, is that these parts, they fuse together. That's the whole concept on that. As it lays one down, the temperature of the next round of layer, bead of layer, actually is hot enough that it fuses and melts the lower layer just enough so they are actually fused together. Now, if you don't have your feed rates correct, or you don't have the temperatures correct, or other environmental factors are involved, you could have parts that are weaker. So it's good to do a couple tests, do some samples, and then break them and see what you come up with. So, and I was always with aircraft parts, always concerned about the strength of parts. So obviously, each part that you create will have to have some type of testing involved to make sure that it meets its design standards that have been spec'd for it.
Victor's wondering, he says I'm curious about the material. Does it come in little balls of plastic or powder?
Oh, sure.
When changing, is
The,
there a cleanup when you change your material, and what kind of costs are
oh, sure.
associated?
Oh, sure. Currently, I would just give you the two most common ones available now are ABS and PLA. So ABS plastic and polylactic acid. Both come in a roll of a roll, kind of like fish and tackle type of stuff. But it's the diameter of the filament is about 1.75 millimeters and 3 millimeters are the two common thicknesses of the filament. So it'll come in a roll, typically about they're sold at 1 kilogram, so 2.2 pounds will run you about $22 or so. It's about $10 a pound for filament these days, and that will make 1 pound of a couple pounds of filament can make a lot of parts.
Andy just says, I think this would be useful for making slightly larger parts out of wax for use in making castings using the lost wax method in a foundry. Will these printers make things in wax or just plastic?
There's multiple people who have been experimenting with this capability, and they've done lost wax with 3D printing. They've actually used a couple different materials. I can't think of them off the top of my head, which actually they print out and use it for lost wax type of molding. So that is definitely a possibility with this.
Cool. Lionel asks, have you used Shapeways to farm out printing? And it says they have a wider choice of materials, including direct metal parts.
Well, there's a lot of different vendors out there that you can, if you don't have your own 3D printer or you don't want to get involved with it, you can actually have an idea. People will design it for you and 3D print it and send it back to you, and either in different materials and metals and things. If they do, laser sintering of metal or 3D printing or fixed, multiple different processes, and there's companies out there that do that. I've never used them just because I have my own equipment, but those options are out there nowadays that really weren't available just a few years ago.
Sure. Just a comment from Dan. He says a good way to get into this is to find a local maker space that has a 3D printer and the software.
Well, sure, that's a great idea. It's and the great thing about the internet is you can just check out Makerspace and find one. Great idea.
So Walt's wondering, can you print a hybrid part that uses 2 or more different materials?
Yes. In fact, that's quite often done recently. In fact, the printer I have, because it's a dual head printer, that I can put ABS in one, and then there's a new filament out there. The name escapes me right now. But as you print with it, you can, a couple things you could do with a dual head printer. You could print with different colors. So you can make a part with in this case, 2 different colors. But what if you wanted to have different support structures underneath it? There's actually I think it's a PVA-based filament, which is polyvinyl acetic alcohol, and after you're done printing it, you drop it in water or alcohol, and the support structures fall away from the actual part. So that's been done, and it is available. Although those filaments tend to run a little expensive now, there's a few other ones that are less expensive and use different chemicals to dissolve away the support structures. But just a little quick note on the supports. You'll be surprised how well 3D printing works without any support at all. Obviously, there's some instances where you do actually have to have an underlying support to do that. But the 3D printers are designed to do something called bridging, which basically jumps from one pylon to another and stretches a string kind of like a spider does, and then it starts to do that a few times and starts to build right over top of it. It's really interesting and really neat to see, but that's one of the capabilities of most 3D printers.
So is the printing speed affected by the amount of material deposited, or simply the volume that needs to be scanned?
let's see here. The printer speed is really determinant about typically the heater section. The extruder can only throw out so much can only melt so much or keep up so well with the amount of filament you throw through it. So most of these hobby 3D printers have nozzles that are about 0.4 millimeters. Now people have put smaller ones on there and up to say 0.5 to even up to 0.1 millimeters. But I think it has mainly to do with the amount of heat that the heat chamber, the extruder, the hot end can actually keep up with how much filament you throw through it. So with most of ours, we're kind of limited. But I've printed at 0.3 layer height, and that builds apart pretty quickly. And but I do have to slow it down a bit. There's a calculation on one of those reference sites that I put there that actually will allow you to determine what your printer speed should be based on what your printer can do. So that's a way to start to figure that out.
Jill's wondering, you mentioned some of the beds that the material's deposited on are hotbeds. What does the hotbed do?
Sure. The heated bed, it's interesting that as these materials heat up, they get really sticky, and as they cool down, they have a tendency to shrink. And with that, in the case with a heated bed, it sticks. The materials typically stick better to it, and also there's typically a surface prep that's done to the beds. Most people either use for lightweight parts or parts that don't require a lot of adhesion. Simple things like a hairspray actually works pretty well. PVA in the hairspray sticks to the parts, and if you heat it up, it gets really sticky and holds the parts down. But it's only so strong. Another bed adhesion practice is to use basically Elmer's glue stick, glue stick, and then put a layer of that down, and it works really well. But the heated bed allows these parts to stick down very solid, and that's probably one of the most critical aspects of 3D printing is getting your parts to stick to the bed. So having a heated bed allows these parts to stick down so that as they start to grow and expand, all those forces of them wanting to shrink down will actually will make them warp and pull off from the heated bed. So by having a heated bed, it mitigates that and allows the parts to stick better.
A few questions about cost. Give us an idea about the cost of the materials. Say, for example, that really cool stick grip you had. What's the cost of that in material?
Oh, interesting. I would have to call it up, but let me think here. Let's see here. I have to go by weight, but that grip probably costs, well, I know plastic costs roughly $10 a pound. And if that weighs 3 ounces, let's see, we're about a fifth of that, so I mean, $2 or $3 at the most for something large and solid like that.
Cool. Brian's wondering, when you get to the print stage, can you work totally offline?
Yes. So there's a couple different ways to do that. Some people have hooked up little print boxes with, if anybody's following, if you're a techno geek, you know what a Raspberry Pi is. And there's a software you can put on this little microprocessor that allows you to send the instructions or the G code out to this processor, and that little gadget works as a print server for the actual printer. So there's one way to do it. That's one way to do it. The other way is to save your design or your G code on a SD card, and most of these printers have a little slot where you can put the SD card in, and it will print right from the SD card. So you don't have to have a computer full-time attached to it.
Scott's wondering, in the example of the Piper knob, how would the material hold up to sunlight? Would you need to protect that in any way to protect from sunlight?
I would imagine that a red knob in this ABS plastic exposed to UV for quite a while would probably, my guess is it would change color. So my guess is that some type of UV clear coat should probably go over top of it.
Dennis is wondering, is it possible to embed LEDs and or wires?
Oh, sure. Yeah, you know, whatever you can come up with and design into your part, you could easily do that. What I found recently on that kind of a fun little thing to do with that that Stratex case that I put together was one of the new filaments that I've been experimenting with was the PETG, and I've got some clear filament, and this looks just like well, it's obviously clear, about 3 millimeters in diameter. And what I did is I designed holes in that case, and once it was done printing, I just pressed fit little sections of this LED clear rod into it, and that turned out to be an LED lens. So the LEDs on the Arduino and the other like the GPS and things that are inside that that Stratex case actually come out on the filament of clear. So it's as an example of how to use some of these materials.
David's wondering, does the process emit an odor?
Oh, good question. PLA is fairly odorless. ABS puts out a slight odor, and you probably want to work, you know, there's questions about styrene and things like that, so the general idea is to have a vented area for if you're printing ABS and work at your own risk here, but typically very little odor at all. It doesn't bother me at all, I guess because I work with composites, and most of those don't have odors either, but so there's always something in the air on occasion.
Right. Andrew's wondering, what happens if you run out of filament halfway through a print?
Well, he had poor planning to begin with, but there's a setting on some of these, and the one I have, that says pause, and it'll give the option to change filament, and it will back out the current filament, or you can cut it off, pull it out, put a new one in, and continue on. So you'll have to watch. The only thing with that is you have to watch. So if you get close, you need to stop the machine manually. It's not, unfortunately, the machines don't have the monitoring capability, although that could be designed, you could develop it, I suppose, to watch the filament and stop or pause all by itself. But currently, you just have to watch it yourself.
So Walt asks, how do you change the part density? Do you change the print head speed?
Oh no, this is really cool. In fact, while you're here, I think I can call this up. I'll pull up a part and I'll show you this real quick. All you do is we'll pull the part in here, and we'll just do add file. What's a kind of fun one? If I can find the control stick in here. Yeah, I can't find it right off the top. But let's say we pull in a something thick. What do we got here? Well, here's the ADS. Well, that knob. That knob's pretty good example. So paper red knob. Open that up. Move to platform. So first thing you do, really, after you get the orientation set, click that, is all right. And assuming I had the right filament, I'm going to leave it on the white one, so I think you can see it a little better this way. So to change the density of the part, it's all in the settings part here. So in this case, if I go to my infill, I think you can probably see that here. It'll pop up in a second. Here are the infill. I've got my infill density set at 98%. I can go all the way down to like 0% if I wanted to, but let's just hit 10% for now. And I'm going to print in hexagonal, which is basically honeycomb, and I'll hit print. Let's see, move to platform, okay. And print preview. Now you can see if I go in and take a look at this, as I look inside the piece here, check the honeycomb there. It should pop up in a second. So it's printing honeycomb inside this piece, only at a 10% fill. So it does it right in the settings. of the software. So here's one that I did at 10%, so cancel print. And here, let's do one at, change the settings here, change the infill. Now this time I'm going to go to like, let's go like 80%. Hit OK. That's the only thing I've changed. And hit print. And it'll figure it out. We'll hit print preview. And we'll look inside here, and now you're going to see, oops, the density of this. Look how intricate these parts are, and it'll just fill itself in with a bunch more filler, and then you could go all the way up to 100% and make a solid part. So that's how that works.
Wow, that's cool.
Yeah, all done. So you're printing your own. Yeah, you're printing your own honeycomb, which I find awesome.
Yeah. Well, the software just to model that is very cool. So David's wondering, what free CAD software do you suggest based upon ease of use, availability of online courses, and compatibility with the different 3D printers and slice software?
Well, it doesn't matter what CAD package you really pick, because each one is going to export to an STL file, most likely, which is typically the file format that all 3D printers are going to read. So once you realize that, it's a matter of what your budget can allow, and go from there. I like using AutoCAD Inventor. It's expensive, but you know, I like the capabilities that it has. Fusion 360 just came out, and it's a lot like Inventor, but there's a learning curve with most of these. But it's free, and it's designed by AutoCAD, and it does basically lots of the same features, although it doesn't do analysis like Inventor will do. It will create the parts. The other one, if you want to, I guess, dumb it down even farther, there's one called, it's in the presentation there, but 123D, I think also Autodesk puts out, which is very similar. It's even simpler than that one. So it really depends on the complexity of parts you want to design, and whether you want to keep them stored on your own computer or in the cloud. So those are some of the factors to think about.
Can you take an existing part that's suitable for printing and import it back into CAD software to modify it?
Yes. Yes, to a degree, and it depends on what the original part file is. In many of the parts that are on, say, Thingiverse, if they give you the parametric drawings that are passably in SolidWorks or Inventor, you can pull those in and manipulate them any way you want. If they just give you what I consider the mesh or the STL file, there's other programs that allow you to do manipulation of the part, like you can change the size or put holes. I mean, it's difficult, but you're very limited if all you have is the STL file. Now, thinking about it, if you have a scanner, you could actually possibly take the part, rescan it, and start from scratch and manipulate it that way. But that's the starting point, really. So the parts that you get, it really depends on what the file format is to begin with.
Roger's wondering, is multi-part epoxy material being considered?
Multi-part epoxy. Well, my guess is yes. I don't know exactly, but I think the next step for some of these these 3D printers that are available to the hobbyist or consumer is to monitor the temperature of the actual flow that's coming out of the head. Currently, they monitor the heat chamber or the hot end, but what needs to be monitored is just before it gets laid down, what the the current environment, and that would allow proper fusing of the filament every single time. Right now, you have to just trial and error to figure that out. With a caveat that you probably know what is going to work, but there's changes in that. With that, if we went to a two-part epoxy that basically you could control, have better control of the substrate temperature and the hot end, You could have these parts shoot out, and by the time it comes around for the next layer, it would be hardened up and ready to go. Now there are UV curable filaments or resins out there that I should probably talk to PTM and W about and see about if they made an extruder that put out UV curable. Just think about it. You could have a UV light that instantly sets it within 5 seconds, and then it lays down another layer, and now you'd have epoxy parts. Now with that, you'd have to think about, can you get glass and dry fibers to come through the head or things like that, because in itself resin is only so strong, and most composite parts get their strength from the carbon or the fiberglass, not the resin. I digress.
Interesting. A couple of questions about scanners. So wondering, how do you scan a 3D part, and are there, what scanners are available? Do you know?
I've looked into it, and there's, as a hobbyist, I think there's ways you can build your own and look into it. Once you have a 3D printer, you can actually print the parts to make your own scanner. But generally speaking, a scanned part will always need some type of cleanup. So what I mean by that is the part will come in as a rough solid with shapes that have to be manipulated and smoothed out. So it really depends. It's a good starting point, a 3D scanned object, but with a lot of CAD experience, you can clean them up and then I guess print the part per se. But it's not something that's just how can I say, as simple as it sounds. I would put it that way.
Rodrigo's just wondering about, buying a 3D printer versus paying for the printing service. Wondering if you got any pros or cons you'd like to talk about that.
Since I'm at heart a do-it-yourselfer, I couldn't pay someone else to do it, and that's the way home builders are for the most part too. Is we're building our own airplanes. Why would we buy one from someone else? So generally speaking, I suppose if you're not the guy who wants to figure things out and tinker and do all this stuff, sure, go right ahead and pay somebody to do it. But I just find it's more satisfying to design something and have the part sit in my hands within an hour than waiting a day or two or something for someone to get back to me.
Yeah. On that, then, Scott's wondering, he says, sorry to be too specific, but do you know what the torque of the stepper motors on your mostly printed CNC is?
Oh boy, it's not off the top of my head. It's pretty. They're not. They're only NEMA. I'll just put out. They're NEMA 17 motors, and if you go to, it's a great website. But if you go to the MPCNC download at Thingiverse, there's a website called Vicious Cycle, which is a great website. Vicious Cycle, I think or Vicious One. That's the company name, and they have the stepper motors for it, spec'd out for it. They're not heavy duty, but because they're used in tandem, there's a heck of a lot of torque that holds this thing in place.
Dan's just commenting. He says that SLA printers use UV curable resin, but it's a different process than FDM printers, like
Right.
what you're showing.
Mm-hmm. Right. It's a completely different process, and you would have to take a look at how strong those parts are compared to the known properties of like ABS and PLA. From my experience of just looking at SLA types of printers, yes, they're fast and they're great for modeling, but I don't think they're going to give you the strength. And someone can correct me, but I don't think they're going to give you the strength of something like an ABS part or even a PLA type, or nylon for that matter.
David's wondering, do you know, will a hot melt glue stick to PVA? It says he's thinking about embedding wires.
Will it stick? I think so. Yeah, I don't see why it wouldn't.
Mm-hmm. So Ken says, how much time did you spend in designing the Piper knob? Was it scanned or designed from scratch?
That knob was designed from scratch. I was looking at something we could actually make for the presentation tonight, and I came across. I just looked for knobs, so I came across the net. I found something that looked. It was the Piper knob. Someone made basically a knockoff and sells them now. And I thought, well, I could probably dupe this, and it took me literally 5 minutes to think about the size, because as a pilot, you know what a knob should feel like. So I add some dimensions to it, and it showed that it had a 1032 thread in it, so I put that in there, and then just sized it up, and that was all there to it. It really didn't. After you get the I guess the experience with using CAD, this whole thing came together. I don't think I spent more than 10 minutes designing that knob.
Wow.
Based on a picture.
But you know what you're doing with the software too.
Right, and that took a little time to do, but with the CAD software now, it's light years ahead of what it used to be just even 5 or 6 years ago. I know that most of us started out maybe doing CAD with AutoCAD back in some early versions, and or maybe some of the early, I think it's called Design CAD and things like that were almost free. There was a lot of drawing of lines and manipulating those and to get a solid part. It was just a lot of work. Nowadays, you draw a profile and extrude it or rotate it or coil it, and you're done in just seconds, basically. You can design a part that would take probably 3 or 4 hours. 10 years ago, you can do it in like 5 minutes or less.
Amazing. Yeah, Andy's just wondering if you could just speak briefly about the availability and cost of scanner machines that can be used to replicate existing parts. And are there any multifunction machines, scan and print?
I think they're in development. I don't know of any, right off the top of my head, I don't know any scan and print machines out there. And I think thinking of this is that, if you've got a 3D printer kind of dedicated, it's going to be working quite a bit, I imagine. But the scanners themselves aren't that expensive. I off the top of my head, I'm thinking $200 to $300 possibly. But look at even Thingiverse has. If you go on there and look at 3D scanner, and there's a couple different methods that you can, as a home builder or a hobbyist, you can actually make your own, and some are based on couple different methods. Some actually use a the Microsoft Xbox scanner to actually scan in a part that can be used for modeling later. So once again, it's the budget we have to devote to some of these things, and whether it's worthwhile spending multiple thousands of dollars on a scanner, which will give you some very nice parts, or whether you can get away with a $200 or $300 scanner and realize you'll have some touch-up and cleanup to do later on.
So Rodrigo is wondering about subtractive processes. I mean, 3D printing is considered an additive process, but is it possible to do a subtractive process in 3D printing?
Not in it. It's all designed. Well, currently the machines are designed as basically spit out hot glue or hot filament and then lay it on top of each other. There's no currently there's no add-on heads, or it'd be great to have another piece that was already designed in the machine that after it printed it out, it would come around and clean up all the make it down to the 10,000th of an inch. They don't currently exist. Now, I've heard of a startup type of thing, as someone promising something like that for a few $1,000s, but I don't know. It wouldn't be that hard, I suppose. But realize you're taking basically a lightweight machine, because all it's doing is printing out filament, plastic filament, on a fairly relatively sturdy bed, and then when you want to mill something, it has to be locked down solid, and because you have a tool head that's needs to be much more rigid than what a 3D printer ever really needed to be. So you're kind of mixing two things that you're kind of losing out on either one, because the 3D printer can be a lot less expensive to add to do additive manufacturing, and with subtractive you have to use a relatively heavier duty machine to make nice cuts.
Hmm. Hmm. James asks, is a metallic printer available?
Metallic in a plastic metallic, or actually printing metal?
I imagine he's talking metal.
Okay, that's laser sintering, which is actually it's not really printing with metal, although I think early RepRap developers had a way of kind of printing solder, but I have not seen that really done in process. But as far as making printing out solid metal parts with it, that's a process called laser sintering, and there's a few companies out there that are kind of making lower cost laser sintering machines that they hope to bring to market. Currently, I think the cheapest one I've seen is probably around $50,000 that actually works, but the cost is coming down, and even with that, I would say within a few years we may see hobbyist printers that can build solid metal parts. And the process is a bit different. What they typically do is have a bed of powder, and a laser shoots down to it in a pattern and melts the layer, and then another layer is put over top of that of just powder, and then the next round of laser melts that over top of the previous layer, and then you build up these parts so it's quite a bit different, but uses some of the similar technologies in that it's all CNC driven.
Cool. All right, well, we've reached the end of our time and questions here. There's just one comment I want to read. Robert says, wow, fantastic webinar. I can't wait to go get a printer and get started. Thank you.
Oh, great. Well, that was the intent. It's a lot of fun, and it's not that, there's a good learning curve, and but I think there's going to be a lot of usable parts in the future with experimental aircraft builders that they can build with these, and and even reduce the cost of completing an aircraft, because I know all these knobs and features and things that we want cost money, and they add up at the once the aircraft is 90% done and 90% to go, and I think these things would really help. So.
Very cool. Well, thank you so much, Scott, for spending your time with us tonight and giving an awesome presentation. Good job switching back and forth with the CAD and the slicer software and your little webcam there to show us the live part. I think it all went really cool. So great. Thank you so much.
Well, thank you. It's a good opportunity, and I hope people hope you all enjoyed it.
Great. And to all the attendees, thank you so much for tuning in tonight. I think we probably had about 250 or 260 people log in tonight. So great webinar. Thank you so much, everybody. Have a great night. We'll see you next time.